Okay, so let's go ahead and subtract two polynomials, f of x minus g of x. And I made a little bit more space here. We know that if we're subtracting polynomials, that negative sign in my subtraction is going to apply to every single term in that second polynomial, in this case g of x. And so a good thing to do would be to rewrite that original f of x, 2x minus 3, and then minus the second polynomial. It might be useful to put that in parentheses. So if we're going to subtract all of g of x, I'm going to go ahead and put g of x in parentheses, and that way I won't mess up with the negative signs. Here we go. G of x is x squared plus 4x minus 5. And so in the first step, I can do f of x minus g of x. I use parentheses around g of x so that I know that the subtraction is going to apply to every single term in g of x. And then I could do a rewrite without parentheses. Distributing that negative through produces negative x squared minus 4x plus 5. Notice how we've distributed that negative through and everybody's signs change in the second one. Go ahead and share with the class a pair of like terms when I call on you. So what's one pair of like terms now that I've gotten rid of the parentheses and can compare? Caitlin T? Awesome. So we can combine those x terms, right, because their variable component matches exactly. So we'll go ahead and write our answer in standard form. We'll still grab my highest exponent term first. That's the negative x cubed. But the 2x and the negative 4x, Caitlin's identified as like terms. Let's combine those. So 2x minus 4x is negative 2x. Another pair of like terms when I call on you. Casey?
5 and negative 3.
Absolutely. So we've got that negative 3 and that positive 5. Those will combine to give me a positive 2, it looks like. And so we've got a couple pairs of like terms there. And my standard form answer then in green. If we can't get it all, we'll try. Our standard form answer then would be negative x squared minus 2x plus 2. Raise your hand if you have that already. So who had that already? Good job with the negatives. Way to go. Is that right? Did I make a mistake? Everybody good? All right. For number 2, we're not performing addition or subtraction, but rather multiplication. So again, I'll do a substitution of f of x and g of x. In this case, 2x minus 3 in parentheses times my original g of x is x squared plus 4x minus 5 in parentheses. Notice how we're going to take a binomial, right? A binomial, 2x minus 3, and multiply it times a trinomial. That's 3-term polynomial. And so here, we're going to have an opportunity to do a double distributive property problem. So we'll focus in first on that 2x, the first term in that binomial f of x. And we're going to distribute that through the second set of parentheses, right? Term by term in accordance with the distributive property using the operation multiplication. Let's do that. 2x times x squared equals 2x cubed plus 2x times 4x is 8x squared minus 5 times 2x is minus 10x. Well, no, that's not all. Now we're going to focus in on that second term, the negative 3 in that first polynomial, and we'll distribute that through the second set of parentheses term by term. So let's do that. Negative 3 times x squared is negative 3x squared. Negative 3 times positive 4x is minus 12x. And negative 3 times negative 5 is plus 15. Notice how we've taken each term in the first polynomial and distributed it through, multiplied it, that is, to each term in the second polynomial. So we've got a long term, a long list now of terms. We're going to go ahead and rewrite in standard form. So we can scan the problems. Remember, my highest exponent term comes first. That looks like the cubing, but now I do have some pairs of like terms. So please be ready because I'll be calling on you to share with the class. What's one pair of like terms? Heather?
8x squared and negative 3x.
8x squared and negative 3x squared. Thank you. That's one pair. I can combine that to give me a positive 5x squared. As I go for standard form, another pair. Luke? 10x and 12x. So I could also do 10x and 12x, and it looks like negative and negative. Overall, it's negative 22x. And that's everybody. Now we just have the plus 15 filling on the back side. That's not going to combine. Anybody raise your hand if you have 2x cubed plus 5x squared minus 22x plus 15. Did I make it to the end? You did. Excellent. You're going to have one that looks just like this on your quiz. So you'll have a binomial times a trinomial. You want to make sure you're comfortable handling that kind of operation with polynomials. Great. Let's go ahead and take a look at going backwards now. Remember, factoring is undoing multiplication. So let's take a look at numbers 3 and 4. So our first step for factoring should always be the same. Stop. Think. GCF. Is there a greatest common factor hiding in each of the terms that could be factored out in a reverse distributive property problem? But as I scan the terms in number 3, no 1p squared doesn't share any common factors with anything else. So it looks like we're now going to consider a special pattern. Do I have perfect square numbers here? Is 24 a perfect square? No, so this is likely not a special pattern. Then we're going to go ahead and take this trinomial and try to factor into a product of binomials. This is my favorite kind, right? We're going to rewrite this as a product of two binomials where my placement, P and P, right, is going to create an outer product and an inner product that's summed to give me that middle term, negative 5P, after we decide on my factors of negative 24, then multiply to give me negative 24, but sum to give me that negative 5. So everybody, let's go ahead and make my list of factors for the red double underline negative 24. Plus and minus 1 and 24 is one integer pair of factors, but also 2 and 12, but also 3 and 8, and also 4 and 6. Holy cow, we've got a whole slew, right, of choices here. Well, actually, only one of those pairs, right, only one of those pairs of factors is going to multiply to give me the negative 24, but sum to give me that negative 5. Go ahead and share with the class which of these pairings is correct when I call on you. All right, which pairing do we have to use? Carson?
Is it 3 and negative 8?
Yeah, it has to be the 3 and the 8 because one combined with the other, positive 3, when combined with the negative 8, will create an outer product, negative 8p. When combined with my inner product, positive 3p, that sums to give me the negative 5p. Nice job. Raise your hand if you have the same as Carson. P plus 3 and p minus 8, either order, but you have to have the negative with the 8. P minus 8 times p plus 3 is also correct. Good job, you guys. So this is my favorite kind, and you'll have to do that on your quiz as well. Now, the good news is that you can always check to see whether or not you're correct, right? What can we do to check and see if our answer is correct? KDP?
Actually solve it?
Yeah, you could actually multiply this out and see if you produce the original. If you do, then you know you are correct. And so I can do a quick first product would be p times p, an outer product, negative 8p, my inner product plus 3p, and then my last would be minus 24. Does that question mark combine to give me my original? You bet your boots. That's how we figured out my placement of the last. Nice job. Stop. Think. GCF. Is there a greatest common factor hiding in each of those terms in number 4 that would chunk it down to make smaller numbers? Yes, thankfully we're going to get smaller numbers as a result of factoring out my GCF. Let's take out a 3 and an x, and by golly, let's take out 3 x's. How about that? So 3x cubed. Now, we still have parentheses and a polynomial remaining, but what I want to do is check and see who else had 3x cubed as your GCF. 3x cubed is your GCF? Great. What's remaining inside then? After factoring out 3x cubed from each of my terms, what remains inside is x squared minus 16. Is that right? 16? Awesome. Great. So we might be tempted to box this, but there's one just like this on your quiz as well. We recognize 16 is a perfect square, and this is a binomial, x squared minus 16. If that's a binomial with a perfect square in it, then it likely came from a special pattern. So let's go one more step. I'm going to go ahead and keep this 3x. Wouldn't it be sweet if I didn't flip? That would be pretty sweet. Yeah, I'm going to keep that 3x squared in the answer. That was awesome. Totally worth it. But I'll rewrite this blue binomial as a product of two binomials, right? Same entries, opposite signs, right? What times itself equals x squared? Oh, x and x. What times itself equals 16? Oh, 4 and 4. Is my last term positive or negative? Well, it was a negative 16. Therefore, should my signs be same or different? They're going to have to be different. So one positive, one negative. And that's good news because now when I multiply that out, I would create an outer product, negative 4x, when combined with my inner product, positive 4x, sums to 0, and that's why there was no x term in the original binomial x squared minus 16. Awesome. What questions do you guys have about today's golf? Okay, then let's go ahead and take care of your assignment number 4. At this time, I'd ask that you take out your worksheet number 4. Make sure that your name, first and last, is on top, and give yourself credit for those you completed. I'm going to go ahead and pause the recording now while we check our answers, but then I'll resume it after we pass in our homework so we can begin our quiz review discussion. Okay, ladies and gentlemen, let's look at our final days remaining in the semester. So, today is day 5. We're going to work on our factoring review worksheet number 5 after we do a couple problems together. You picked up the semester review packet on your way in, right? It's a big packet. We've organized it by unit, starting with unit 1. You don't have to complete the semester review packet before next class period. We just wanted you to have it before the weekend so everybody had over a week to work and prepare prior to your final exam. However, that said, I would begin working on it. I would just start working with the unit 5 stuff towards the back of it, because that's the stuff that's going to be on your quiz also. So it'll be a double bang for your buck. Once again, I would start working on your semester review packet, and I would start at the back at unit 5, right? Because that'll help you prepare for next class. What's next class? Well, that's day 6. We're going to be taking your unit 5 quiz. So your unit 5 quiz will be taking next class, day 6. Then you'll have an opportunity to work on your review packet afterwards, along with solving equations review number 2. Today you should have picked up solving equations review number 1. This matches almost exactly one page on your final exam that involves solving equations non-calculated. It's just like your pre-test that you took the first day of class, our mid-interval quiz that we took back before before logarithms, and it's going to resemble one page front and back on your final exam non-calculator. So basically we're giving you a page of the final exam in advance, but with different numbers, so that you can work and prepare for your solving using inverse operations. Again, that was a central focus for the year and will continue into next semester. And then day 7, that's our last day of the semester, right? Next Thursday for us, A day, and Friday B day. That's when you're going to take part 1. Part 1 is non-calculator, and you can see what kind of exercises are non-calculator. Based on the last page of the review packet, we went ahead and divided up the problems into calculator allowed versus non-calculator and included that so that you could direct your study accordingly. All right, so let's go ahead and take a look at our final exam review schedule. There's 4 different sections, right, that I have, 4 different sections, so each one is going to be assigned a different room, but they're all near here. So let's go ahead and see where ours is. So advanced algebra, we'll be taking that on the first exam day, that's Tuesday, January 19th in the 4th block time slot, that's 1:50 to 3:25. And for our class, you'll be taking that right next door in 2203 with Mr. Vesbach. And so right next door, 2203, and let's write that down on our sheet. So we'll be taking it in 2203. That's right next door with Mr. Vesbach. Everybody have that down then? So room number for us is 2203. You must bring your completed review packet. That'll be like your ticket to take your final exam. Pencils and a calculator. During final exam week, you'll be taking the calculator allowed portion, so you want to make sure you have your calculator with you. Okay, so once again, Tuesday, January 19th, 4th block time slot, 1:50 to 3:25. And you guys are in 2203. That's right through this wall in Mr. Vesbach's room. 2203 is right next door. Next Wednesday, the 13th, is final exam review night. And so you'll have opportunity to come and ask questions of advanced algebra teachers. If you're not doing something else during that time frame, 3:45 to 5:15, come for all or part of it, right? And you can work and ask questions with your semester review packet, and that's a great resource to take advantage of. Casey?
Will the answers to the review packet be on Moodle?
They should be. Yep. And they might not be yet, but they will be soon. I also have hard copies that I'll be taping on, and even if it's B-Day, you can still come by if that's your study hall, and you're welcome. Even if I have AP Calculus during that time, just go ahead and work on the back, and you can work and check your answers with the review packet key. I'll put them up because I want you guys to have access to that, okay? So you can come in here and work during your study halls, right? And that's fine with me, as long as you don't disturb my other students, because I want you to have plenty of time to work and prepare. Other questions about that? Thanks, Casey. All right. We filled that in, and we're good to go. Let's go ahead and consider our flow chart then on your notes. So everybody, we've got a flow chart for our notes. We know that in general, when we go to factor a polynomial, right, we always want to stop think GCF first. And so that's always our first step. See if there's a greatest common factor hiding inside each of those terms that I could factor out in a reverse reciprocity problem. Even if I have to continue factoring with a different strategy after that, it'll involve smaller numbers as a result of factoring out the GCF. So our first step is stop, think, GCF. Then, if I have a two-term polynomial, right, or there is no GCF, but it's two terms, it might be a special pattern, right? If it's a two-term polynomial that is a binomial and contains perfect squares, then maybe it was the special pattern a squared minus b squared. We've seen time and time again how that same entries, opposite operation. So that would be something like a plus b times a minus b if we were to factor a difference of perfect squares. We might still have a special pattern even if there's three terms, but then it would be a sum, right? A binomial squared, the square of a sum, or the square of a difference. A squared plus 2ab plus b squared. We can factor that a regular way, so we don't have to memorize this necessarily, but we've seen how that will always end up being a plus b times a plus b. And you could write that as a plus b quantity squared if you so desired. We also know that a minus b, the square of a difference, quantity squared, would result in a middle term always, minus 2ab plus b squared. If it's not a special pattern, well, you could still undo a three-term polynomial, right? By undoing FOIL. That's where we consider the outside and inside product. They would sum to give me that middle term in that three-term polynomial. So undoing FOIL, this is our main one that we spend most of our time doing. And my favorite one because each one is like a puzzle. And lastly, think about the strategy we used last class. If there's four terms, if it's a four-term polynomial, then we could factor by grouping, right? We could factor by grouping. And that was our last strategy, our final factoring strategy from last class. All right, but we want to make sure that we're not just factoring. You also need to add, subtract, and multiply polynomials. So let's take a look at our quiz review. Recall we can distribute that subtraction, that negative, through the second set of parentheses. On your quiz, don't multiply 2x cubed times 4x cubed. This is not a multiplication problem. This operation is subtraction, and so this is just a subtraction problem like number one in the Bellwork. You can rewrite without parentheses. This would be 2x cubed minus 3x, and now distribute that negative through the second set of parentheses. That becomes minus 4x cubed minus 7x minus 5, and now I can combine like terms. Keep in mind that your leading coefficient, right, your leading coefficient comes from the highest exponent term, so it looks like we've got 2x cubed minus 4x cubed, so negative 2x cubed would be my dominant term. The degree would be 3, no x squared term. Combining like terms, minus 10x and still minus 5. What operation is going on in number 2 between the negative 3x squared and the x cubed minus 5x minus 11? What operation is going on there? Mark? Multiplication, right? Multiplication. And so in number 2, we are going to take this outside factor and multiply it through the parentheses. Does everybody see the difference between number 1 and number 2? Number 1 was a subtraction. Number 2 is a multiplication. Let's go ahead and do that. So we get negative 3x squared times times x cubed is negative 3x to the 1, 2, 3, 4, 5 plus, because the negative times the negative is a positive 15x cubed. Plus, because the negative times the negative is a positive 33x squared. Do I have any like terms that I can combine here? Do I have any like terms that I can combine here? Aaron? No, we can't combine like terms unless their variable component matches exactly, and here we have different exponents on our x terms, so this is it. This is standard form, final answer. Go ahead and tell the class the degree of this polynomial. Everybody look. What's the degree of this polynomial that I just boxed in red? What's the degree of that? Ben C?
Third.
Third degree is the highest exponent 3? Well, what's the highest exponent encountered?
X.
X to the 5th, so the degree is 5, absolutely. The highest exponent determines the degree of the polynomial. In this case, the highest exponent encountered is 5, so this is degree 5. Now, the leading coefficient is the number multiplier on that highest exponent term. That is negative 3. And so the leading coefficient is negative 3. The highest exponent is 5, so the degree is 5, right? The degree is not x to the 5th, the degree is 5. Leading coefficient, negative 3, and the number of terms is 3, so it's a trinomial. So this would be a 5th degree trinomial with leading coefficient, negative 3. Katie?
So when it's doing like multiplication, you don't do greatest common factor?
Correct. Here we're multiplying or adding or subtracting, right? Versus when we are going backwards, right? Then we're factoring. That's when we do GCF, right? When we already have no parentheses and a list of terms. Here we have parentheses in each case. So that's a good way to kind of recognize. All right, number 3. Number 3 is what operation? Addition, subtraction. Well, this is also multiplication. Isn't this 3a minus 5b times 3a minus 5b? That's what it means to take a binomial and square it. And when I do so, the result is always, always, always a trinomial. So let's go ahead and see that that's the case. Here we go. You can recognize this as my first, right? My first 9a squared. My outside product would be 3a times negative 5b is negative 15ab. My inside product would be negative 5b times positive 3a is negative 15ab again. Both of the 2 comes from that special pattern. And then negative 5b times negative 5b is plus 25b squared. So notice how our binomial squared, right, is just a FOIL problem in disguise. It'll always be a trinomial result. Let's see what we get for my final answer after combining like terms. 9a squared minus 30ab plus 25b squared. And we'll go ahead and box that back. So how do we recognize if we're doing a factoring problem versus a different problem? Well, if we start out and we have parentheses, then we're looking at addition, subtraction, multiplication, right? Versus number 4. Number 4, we're going to go ahead and factor that polynomial completely. There's no parentheses here. Now we're going backwards, right? So now let's go ahead and stop. Think GCF. Is there a greatest common factor hiding inside there? Well, by golly, it looks like 5 divides evenly into each term, but so does a and b squared. Is that right? So we've got 1, 2. Yep, there we go. 2 b's in everybody. So let's go ahead and factor in a reverse distributive property problem. And what would remain inside? Well, we'd still need a squared minus 4a and then plus 2b. And I think that's everybody. So it looks like after factoring out the greatest common factor, we still have a squared minus 4a plus 2b. What kinds of questions do you have at number 4? All right, stop. Think. GCF. Is there a greatest common factor hiding in each term in number 5? Yes, there is. Let's go ahead and factor that out in a reverse distributive probability problem as my first step. So it looks like a 3 and an x. Let's see what remains. After factoring out a 3x, we still have 4x squared minus 12x plus 9. Some of you may be tempted to box this answer and move on to number 6. However, what do you recognize about this blue trinomial? What kind of numbers are 4 and 9? Margot? Yeah, perfect squares, and so this might be a special pattern. Let's see if we can't go another step. So we'll keep our 3x as part of my answer. It was part of the original problem, hiding inside each term. It'll be part of my answer. But let's break up that blue trinomial, 4x squared minus 12x plus 9, into a product of 2 binomials. What times itself equals 4x squared? 2x and 2x. What times itself equals 9? 3 and 3. Take a look at my last term. Is it positive or negative? Well, it's positive. So are my binomial signs going to be same or opposite signs? They have to be same. In order to multiply together and produce a positive result, they must be same signs. Given that my binomial factors have same signs, are they, and my middle term in the trinomial is negative, are they both going to be plus or are they both going to be minus? Oh, they both better be minus. So we might see this as 3x times 2x minus 3 quantity squared. That's fine if you leave it like this on your quiz as well. And we could also do a quick check for my green binomials, 4x squared minus 6x plus 9. The two negative 6x's combine to negative 12x. That works. Awesome. Number 6, stop. Think. GCF. Is there a greatest common factor hiding inside? Yeah, there is. 2q squared. Remaining would be q squared minus 36. Again, don't stop. I've got a binomial. That blue binomial contains perfect square number of 36. So I can keep going and factor that difference of perfect squares into a product of two binomials. Let's do it. So 2q squared. And let's break up that blue binomial. So what times itself equals q squared? Well, q and q. What times itself equals 36? 6 and 6. So what will my signs have to be to guarantee that my outer and inner product cancel one another out? Right? What are my signs going to have to be here? Heather? So in order to make the last term negative, that negative 36, we need opposite signs, right? And then that will make an outer product and an inner product that are exact opposites and cancel each other out. Good. This would be plus 6q for my outside product, minus 6q for my inside product, sums to 0, and that's why we don't have a q term in this blue binomial. Nice job. Okay, ladies and gentlemen, we're close. So stop, think, GCF. Nope, nothing hiding. Let's go ahead and set up our parentheses and see if we can't factor that trinomial into a product of two binomials. So we'll go ahead and set up my parentheses and fill in my variable x and x. Next, we'll consider our last. Our last term in this case is negative 3. So we know that the only integer pair of factors that multiplies to give me negative 3 are plus or minus 1 and 3, which means my only choices, right? My only choices for entering are 1 and 3. Hey, that's great news. Except we still need to determine the signs, right? Are my signs in the binomial going to be same or different, given that my last term in my original trinomial is negative? So am I going to have same signs or different signs here? Well,
Let's see.
what, right? What times what is going to equal negative? Yeah, they got to be different. One has to be positive and one has to be negative. That's good, right? Because a positive times a negative equals a negative. I need opposite signs here. But I need to purposefully place those signs, right, such that the sum of the outer product and inner product is negative 2x, that middle term. So what are we going to do? Well, we have to put the positive somewhere and the negative somewhere, right? Which is going to be which, so that they sum to give me that negative 2x. Jackson?
We have negative.
Absolutely. Notice the placement of the negative with the 3 creates an outer product of negative 3x when combined with my inside product. Plus 1x gives me the overall squiggle underline negative 2x in the original. So it matters where the signs go. Good job, you guys. And we can always check that. In fact, on your quiz, you can check this by multiplying it out. X times x is x squared. Outside product, negative 3x. Inside product, plus 1x. Last, negative 3. Stop. Think. GCF. Is there a greatest common factor hiding inside? No. Is 6 a perfect square number? Is 5 a perfect square number? No, and so this isn't a special pattern, which means that we're stuck listing the factors of the first and the factors of the last. This is the hardest kind, where we must consider the interplay of the outside product and inside product such that they sum to create that middle term of 13. Let's do it. So my factors of my first include plus and minus 1 and 6, or 2 and 3. My factors of the last include plus and minus 1 and 5. Let's make some parentheses pairs, and remember, don't be afraid to make a mistake. So it's okay to make a mistake. Each mistake is just going to be one step closer to the right answer. So I'm going to go ahead and make a couple pairs of parentheses. All right, I'm going to try a 6x and an x. I'm going to try a 3x and a 2x. I'm going to try a 1 and a 5. I'm going to try a 5 and a 1. I don't know if these placements are correct or not, but we have to be willing to make a mistake because each mistake we make will just bring us one step closer to the correct placement. Let's currently consider our outside product in the top one. 6x times 5, that's 30x. My inside product would be 1 times x is 1x. Will that sum to give me the 13, positive or negative? No, so that placement's no good. Let's try flipping those. Now my outside product is 6x times 1 is 6x. My inside product is 5x. Can I sum those to get 13? No. Well, this one's right out the window. So that's not bad. That's good. We know that it's not the 6x and the 5, right? And the x and the 5. We know it's not that, which means it must be a 3x and 2x problem. Let's check. Here we go. Outside product. 3x times 1 is 3x. 5 times 2 is 10x. By golly, can we get to 13x? Well, we could so long as the signs worked out. So this is a potential candidate for victory. Hooray! Except for one problem. Is my last term positive or negative? It's negative, which means my signs are same or different. Well, different. If my last one is negative, that means I have to have different signs. And so this can't be the same signs, positive 3x and positive 10x to get to 13x. They have to be different. So this is not the winning placement. Darn it. That's all right. We haven't tried this yet. Now my outside product is 3x times 5 is 15x. My inside placement is 2x. Can I combine 15x and 2x, opposite signs, and get to 13x? You bet your boots, so long as I make the larger product positive. So I better put the plus with the 5 to make it positive 15x, and the smaller product negative. So I'll put the negative with the 1 to make my inside product negative 2x. Now we get an outside and inside product that sums to give me that plus 13. That's a sweet problem. I love it. I love math. What's the strategy, right, that we use to tackle a 4-term polynomial? So what was the name of the strategy that we use to tackle a 4-term polynomial factorization? Eric? A special pattern with 4? Grouping, right? Grouping. If we have 4 terms, then it might be a candidate for factoring by grouping. If I can divide it into 2 groups of 2, each of which share a greatest common factor. So let's consider the first 2 terms. X cubed and 2x squared. Do they consider a GCF? Do they contain a GCF? Yeah, so I could have this be my blue group, perhaps, my first group of 2. My second pair, negative 3x minus 6. Do they contain a common factor? They do. They both have a negative and a 3. So I'm going to go ahead and leave it as is and not reorder. Now we'll focus in on the blue group. In the blue group, what's the greatest common factor? Well, x squared is the greatest common factor. If I were to factor that out, it would leave me with x plus 2 remaining. Now we'll focus in on the green group and say what's the greatest common factor present in the green group? Well, they both have a negative. And they both have 3. So I'm going to factor out a negative 3. Remaining inside would be positive x plus 2. And that's good news because after my first layer of GCF problems, have I created a common group? By golly, we have. My common group is x plus 2. For my final step, I'm going to factor out that common group, quantity x plus 2, as the GCF in each of those big old terms. The blue term and the green term. And after doing so, what remains? Well, after pulling out an x plus 2 from that first blue group, all that remains is the x squared. So all that remains is the x squared in the first group. After factoring out an x plus 2 from that second green group, the only thing that remains is negative 3. So while factoring by grouping is a distinctly different process than undoing a trinomial, right, using a FOIL pattern, we can still check with the FOIL pattern. Take a look. If I were to multiply this out, I get x cubed minus 3x plus 2x squared minus 6. Could I rearrange those and get the original? Yes, I've created each of those 4 terms in the original. Even though they're out of order, they would still be rearranged. So I'm going to box this as my final answer. That's pretty sweet. What kinds of questions do you have about our Unit 5 review problems? So what's up? Well, there's your printable. Here's some factor completely problems for you to practice. We've got a couple of different steps here. We've got stop, think, GCF, and continue the party. Those should be 3 on a page, yes? And then our closure. So let's go ahead and stop, think, GCF. Go ahead and try these with your partner. We'll check them together. And then we'll complete your closer, and I'll be perfect timing for our 2-hour early release. Keep in mind that we've got a shortened schedule today. So these 3 are with your partner. So it's okay to talk. I want you to talk. These 3 are with your partner. And then we'll check them together before your closure.
Alright, so let's go.
Stop, think, GCF. Keep going. These involve multiple strategies.
No, so it's gonna be, one's gonna be X, it's gonna be 2X. Squared. What?
Alright, so you can take it back to the first, and back to the last. And see if you can break them up. So the factors are 2, minus 1, 2. Your factors of 21 include.
Alright. Wait, there's only one.
So keep your X on the right here, on your line 1, keep your X down right 2 parentheses.
So,
Yes.
okay, so now we need to
Put it as 2X and X. And now mess around with the 1 and the 21 and the 3 and 7. You're trying to get to the left.
we have to do it like this. We're not consistent right now. We're done. We're not done. No, we're not done. We can go another step. Okay. Go to 2. No. We're at 2's perfect. No, 1 and 1.
Okay, ladies and gentlemen, because of the 2-hour early release schedule, we're going to have to bump up our practice time a little bit. So what I wanted to do was share the answers, knowing that not all of you have finished each of these 3 practice problems, but I want you to get them down so that you can use this to work and review over the weekend. Once again, number 1, I went ahead and did a GCF problem. I factored out an X first, but then continued the party with that green trinomial and factored into a product of 2 binomials. A quick check, my outer product, negative 14x. Combined with the inner product, positive 3x, gives me that negative 11. So this one is a keep going.
Keep going.
Take a minute and make sure you have this in the margin even if you're not done. And we have to go quickly. Stop, think GCF. My black trinomial will continue factoring as well, so I did 2x times the 4 gives me the 8x, minus 3x gives me the plus 5x, and opposite signs makes negative 12. So go ahead and make sure you have this one down in the margin if you hadn't already. These are a little bit more complex than the ones that you might have to do on all your quiz. But we don't want to shortchange your education by not challenging you enough. Lastly, a factor by grouping problem. Stop, think, GCF. Blue group, green group, and we've done lots of these. Make sure you have this one down correctly in the margin so you can go back and finish it. Oh, we're not done. We're not done. What's up? Are you even kidding me right now? Mr. Fritz, are you even kidding me right now? No. Take a look. Our d squared minus 4 could keep on keeping on. What? That 4 is a perfect square, and a difference of perfect squares, we get d and 2 and 2 and opposite signs. Nice job, Taylor, with the heads up. So this one keeps going 2. This one has not 1 layer, not 2 layers, but 3 strategies in order to complete the last one. That was pretty sweet. Okay, ladies and gentlemen, our closer for the day is exactly the flow chart from before that we filled in, so we don't have to do this separately. However, I will point out, right, that you'll get a blank copy of this on your quiz. If you choose to complete it, you may, but it won't be filled in. You'd have to be able to fill it in. So I would encourage you to go back and do your closer again and fill those in. I'll fill them in. Your final exam review packet, the last page has a copy of this so you know which ones are non-calculator versus which ones are calculator allowed. And you've got several assignments. You've got your factoring review worksheet number 5, your solving equations review number 1, and work on your semester review packet. I would encourage you to start with Unit 5 stuff because that'll help you review for your quiz at the same time. Does that make sense? Awesome. I'll go ahead and pause the recording and save that. Great job today, you guys.